Okay, I'd like to start class today with a tricky example of integration by parts. So this is still an integration by parts problem because I have the product of two unrelated functions. I have an exponential and I have a trig. But I want you to set up your tabular method table and try and figure out what the issue is here. Did you figure it out? Do you need to pause the video? Do that if you need to. The issue is that both of these functions, the exponential and the trig, are cyclical, meaning on this derivative column, for example, if I put cosine x here, it's going to go cosine, sine, cosine, sine, cosine, sine, cosine, sine, forever. It's not going anywhere. Same thing with the e to the 3x. E to the x, e to the x, e to the x, e to the x. I may have some signs out front, some pluses and minuses. I may have some coefficients out front, but it's really not going anywhere well, okay? I want to show you how to handle a situation like this. This really only comes up if I'm dealing with the product of an exponential and a trig. So let me put, in this case it actually doesn't matter which one you put as your derivative and which one you put as your integral. I promise you'll end up with the exact same answer. But I'm going to go ahead and put cosine x here. The derivative of cosine x is negative sine of x. And the derivative of negative sine of x is negative cosine x. And I'm going to stop here. With this specific type of problem, you stop when you get back to your original function, in this case cosine x. Doesn't matter that it's negative. I'm going to integrate e to the 3x and I get 1/3 e to the 3x. I integrate again and I get 1/9 e to the 3x. I still need to across. I still need to manipulate my signs. So this one stays positive. This one I put a negative out in front of, which means in total it's going to be positive. This one I put a plus out front, which means it's going to stay negative. So this one is positive, this one is positive, and this one is negative. Okay, I do this. I get 1/3 cosine x e to the 3x. And then the next one I get plus 1/9 sine x e to the 3x. The across one gets integrated. So this is minus, I'm going to put the 1/9 out front, times the integral of e to the 3x cosine x. I hope you can read that. Well, shoot, how would I integrate this? I would integrate this using integration by parts. However, what I want you to know is that the integrand here, e to the 3x cosine x dx, e to the 3x cosine x dx, it's the same as that one. I'm just going to perform some algebra. So I'm going to add 1/9 times the integral of all that stuff, e to the 3x cosine x dx, to both sides, plus 1/9 times the integral of e to the 3x cosine x dx. Negative 1/9 times that integral plus positive 1/9 times that integral sums to 0. And so I'm left with one of those integrals plus 1/9 of those integrals. That would be 10/9 times the integral of e to the 3x cosine x dx is equal to what I had on the right-hand side, 1/3. I'm going to write it like this, e to the 3x cosine x plus 1/9 e to the 3x sine x. Somewhere along the way I lost a plus c, so let's put it back in here. I'm almost done. My question was, what is this integral? And I have this integral with a 10/9 out in front of it. So I'm going to multiply both sides by 9/10. And that's it. The integral of e to the 3x cosine x dx is equal to 9/10 times 1/3 e to the x cosine x plus 1/9 this is e to the 3x, e to the 3x sine x plus c. So if you have one of these that is cyclical in both functions, I recommend putting the trig in the derivatives column. It just tends to work out better for me. Go until you get back to your original one, which should just take 2 iterations, and then algebraically solve for that integral. Just to let you know what's coming up, today I just have a few extra practice problems. Those are not going to be turned in. They're just going to be done kind of in line with your classwork. Tomorrow, Wednesday, you're going to have more practice. This is a handout of AP style problems. Okay, some multiple choice, some free response. You're going to turn it in as homework number 5. Okay, and then Thursday you have your test. It covers U substitution, partial fractions, and integration by parts. It really doesn't cover any more than what was covered on the quiz. It just covers it in a more rigorous manner. And as a reminder, your homework is due on Thursday. That needs to be stapled, in order, etc. Here is the set of practice problems I want you to do today. I'm actually going to go ahead and just put the answers to these problems up so you can copy both the problem and the answer and make sure that you get those answers. Number 3 here is similar to the one that I just worked with you. So if you're thinking you need an example of that, here you go, and here's the answer. Make sure you can get it. So you have a straightforward integration by parts problem, you have a partial fractions problem, and you have a trickier integration by parts problem. Make sure you can get the same answers as me.